Right. So our next part is dimensional analysis. Dimensional analysis. So this part is very much same as the unit part. Unit part take a my dimensional analysis, right? So first of all, we have to look what is the dimension. So what is the dimension and physical expression or physical quantity? Right? For the dimension, signaling of mana. Mana. It is a physical expression which shows the relationship between fundamental physical quantities and the given physical quantity. Right? So it is a physical expression. Expression it shows us how this physical quantity derived from the fundamental physical quantities. Fundamental physical quantities derived and expression. It is symbolic expression. Dimension of a physical quantity is a symbolic expression of how that physical quantity derived from the fundamental physical quantities. Using fundamental physical quantities. The fundamental physical quantities make a use to and an expression dimension, right? It is a symbolic expression. So, expression we use characters, we use letters to symbolize them, right? So they have introduced some symbolic letters to the fundamental physical quantities. To represent fundamental physical quantities, they have used some symbols. For example, we take length, right? So we use symbol capital. Symbols use right? So for length, we use capital L as a symbol, and dimension of it is 1. Dimension is 1. Right? So these are the fundamental dimensions we use. For mass, dimension of mass, symbol is capital M, right? M. This is not the dimension. Dimension is 1. Dimension is the exponent. Right? Very simple. Like mass can symbolize correctly. Right? Then time. Time, capital T is the symbol, dimension is 1. So these are the 3 fundamental physical quantities which I used earlier, right? And here are the symbols and their dimensions. So other than these 3, there's a dimensions for the rest of 4 fundamental quantities also, but in our syllabus, right, these 3 are the main dimensions. Other than these 3, we use this also, electric current. Electric current. Electric current. Right. So we use capital I. In some books, they have used capital A also, right? Capital A can have amperes, but we use capital I here, and dimension is 1. And for the temperature, thermodynamics temperature, dimension of temperature is theta. Symbol is theta, dimension is 1. Temperature dimension 1. Right? So these are the basic for fundamental dimension. It amount of substance, MOL. Right? Use luminous intensity dimensions, but these are the main symbols, right? So in mechanics, most of the physical quantities were derived using these three. So these are the three main dimensions and their symbols. They were taken, right? So if you take force, dimension of force. This is how we get dimension of force. So how we define force? Go back to the earlier lesson. Force is mass into acceleration. Mass into acceleration. Right. So now how we express force as a symbolic expression using these symbols. So what is the dimension of mass? Symbol is m, dimension is 1. Right? So normally another thing. So we use square brackets when we representing dimensions. We use square brackets, right? Here I also these physical quantities I have written them in between these square brackets, right? So this means dimension of length. If a physical quantity have mentioned right in between these square brackets, which means the dimension of the physical quantity. මොනවාරි භෞතික රාශිය මේ කොටු වර්ණයක් ඇතුළේ ඉඳ තියෙනවා කියන කොහෙන්ද නේද? ඒකේ අදහස් කරන එක dimension. Right? ඒ නිසා මම මේක ලිව්වේ මෙහෙම. Right. මේක compulsory නෑ. But this is the way we are writing. Right. So dimension of mass is m. What is the dimension of acceleration? How we define acceleration? So we define the acceleration again. Velocity over time. Velocity over time. Acceleration is velocity over time. So how we define velocity? Displacement over time. ඒක displacement over time. I time වලින් බෙදෙනවා නේ. එහෙම acceleration දෙන්නේ. So ඒ නිසා ඒක අපි එයාගේ dimensions ගන්නකොට මම මේක දෙනවා තාපොටික dimensions ටික. Right. Then the නිකන් example එකකට ගන්න. Dimension of displacement is m. Sorry, it is L. Length. Right. Dimension of time. Time එක twice තියෙනවා නේද? So it is t square. T square. So finally, mass dimension of force is mass 1 times L1 times T minus 2. L1 minus 2. Right? So this expression have same relationship as the unit of the force. If you remember, unit of the force as in base units, right? This is the base unit. Kilogram, meters per square centimeter. Look at these exponents, they are similar. Right? Here we have 1. Here also 1. Method 1, 1. Minus 2, minus 2. So dimensional expression also have the same exponents where the SI unit of that physical quantity A ටිකම very simple sense. අපි මේ තරම් units dimensions කියන්නේ එකක් තමයි සමහරවිට එකක කියන්නේ but here අපි එක difference වෙනම separately ඉගෙන ගන්නවා. Right? So this is how we express dimension of physical quantity. Right. So now tell me what is the dimension? What is the meaning of dimension? Dimension of a physical quantity is a symbolic expression which represents the relationship between fundamental physical quantities and the given physical quantity. Right? So what are the basic dimensions? For length, dimension is exponent of exponent is 1, symbol is L, that is the power 1. Mass, capital M, exponent is 1. time capital T exponent is 1. Electric current capital I exponent is 1. Temperature theta exponent is right. Then the other important factors, right? So like I said, if you remember, in when we studying units here කතා කරද්දී first day or second day I have mentioned some important facts about units. Like 5 numerical constants. Does they have units? Does they have dimension? Right? If a physical quantity does not have a unit, it also do not have a dimension. Unit එක නැත්නම් dimension එක නැහැ. Unit නැති සියලුම physical quantities වල dimensions නැහැ. Strain dimensions තියෙනවද? Relative humidity dimensions තියෙනවද? Relative density dimensions තියෙනවද? No. Refractive index dimensions තියෙනවද? Right? Efficiency dimensionless. Right? Other than that, to angle measuring physical quantities, plane angle and solid angle, they also do not have dimensions. They does not have dimension. The dimensions there. Angles measure karana a physical quantity, solid angle, plane angle, dimensionless. Then what the angles dimensions? Like sine, cos, tan, tangent value. Right? If we have concerned this physical quantities, sine value or cosine value or tangent value or any other trigonometric ratio, does this x have dimensions? Because in units we have I have told about this. If this x do not have any unit, so therefore it is dimensionless. These terms, cosine, tan, sine terms, they are dimensionless. Dimensions there. Why the dimensions now? If you consider log value of a certain physical quantity, log value. What can you say about this x? It should be dimensionless. Dimension log value. Arambe units or rules of it. Right? The other one. If you take exponent, we consider this physical quantity as an exponent. So does this x have a dimension? It should be only numerical value. A dimension unit table. So these are the main things about dimensions. Otherwise, all rest of things similar, very similar to the units. Simple solid right? Topic dimension analysis. That is the topic. Their dimension of a physical quantity, dimension of a physical quantity is a symbolic expression, is the symbolic expression. Dimension of a physical quantity is the symbolic expression which shows how it related with the how it related with the fundamental physical quantities. Fundamental physical quantities. Right. And the next subtopic is basic dimensions. Basic dimensions. And their symbols. Basic dimensions and their symbols. Right, write down this. These are the symbols and their dimensions. Right? අනිත් ඒවා තියෙනවා. The main things main එක මේ ටික. Right. ඊළඟට important topic, yeah. Important points related with dimensions. Important points related with dimension. First one, physical quantities. Physical quantities. Physical quantities without units have no dimensions. Have no dimensions. Let's write 2 or 3 examples. Strain, refractive index, strain, refractive index, coefficient of friction. Next, second point is solid angle, plane angle and solid angle. Plane angle and solid angle have no dimensions. Second fact. Plane angle and solid angle have no dimensions. Have no dimensions. Right. Third. If sine, cosine or tangent if sine, cosine or tangent value of a physical quantity has considered that physical quantity must be dimensionless. Right. Right. Next fact is, if a physical quantity expressed as exponent, it must be dimensionless. Like it must have no dimensions. It must be dimensionless. Right. Next. Right. Logarithm of a physical quantity can be considered if that physical quantity has no dimensions. Okay. Numerical values. Numerical values phi have no dimensions. Dimensions dimensions no. Plus means, right, which is actually exponent. What is the exponent of? If some physical quantity, let's take it as k, is dimensionless. That means what is the exponent of mass? Dimension of mass. What is dimension of mass there? Exponent this is dimensionless. Should be 0. Dimension में क्या 0? That's 0. Right? Dimension is 0. Taylor 0. आपका एक exponent का तीन के dimension है. Dimensionless being actual value is 1 again. Are you written again? Right? इतना भाई basics ठीक है. Right. Then building यहाँ යනකොට ඔයාලට homework වලට මෙන්න මේක කරන්න වෙනවා දැන් මොකද මම ඒක ටයිම් එක ගන්නේ නැහැ. right මොකද කරන්න තියෙන්නේ අපි units වලට ගත්තා derived units ඊළඟට basic units ගන්න ඕනේ නැහැ basics ටික මෙතන තියෙනවානේ derived units තිබ්බා special names තියෙන ඊළඟට compound names තියෙන right ඒ ඔක්කොමගේ dimensions expressions ඔයා ගෙදරදී ගන්න ලියගෙන right as a compound on the other definitions ටික නේද අපි ගත්තා එක course right you need to write them within bracket within square brackets right so we got the first one I think the first physical component is area it is length into length in my idea length into breadth. Length into width. So dimension of length is L. Square root is 1. So final answer is L. Example here. We take density. Density is mass over volume in million. So mass M, dimension is 1, volume symbol is L, dimension is 3. So you can write this denominator as a negative power. In million. M L minus. ඒ විදිහට මම දැන් 30 ohm මොනින්බා අර ඒවයි මෙන්න මේ ටික පොඩ්ඩක් හරි ස්පෙෂල් ඉවෙන්ට්ස් කියන ඒවයි පොඩ්ඩක් මාක් කරගන්න ඕන පොඩි ස්ටාර් මාක් එකක් දාන්න මෙන්න මේ ටික තරම් කරන්න ඉතින් කියන්න ඕනේ නැහැ ස්පෙෂල් ඉවෙන්ට්ස් කිව්වේ ඒවයි ස්පෙෂල් ටේම්ස් කිව්වේ ඒවයි force ඕනේ force power pressure, frequency, capacitance करना, resistance करना, charge, वैसे के तरह कंसीडर right, वैसे के अनित्तर derived physical units साला आपको मगे मगे dimensions के अंदर एक तो बोर्ड है ना formula of fixed viscosity, surface tension, Young's modulus ये आपको मुझे dimensions निकल expression निकल गया ना dimension निकल समझ over right so units और आपको MCQs टिक नहीं complete कराना up to from 57